everyone. It's time to start talking about more semiconductor stuff. All right, so you had your lesson on diodes, and you noticed that a diode has a PN junction, right? You have the P-type and the N-type joined together, and that the area in between the two is where they're connected, and the P-type is what? Positive, right? Therefore, does it have extra electrons or missing ones? Obviously, it's positive, so it's missing them. And we have the N-type, which is the negative side, and the negative side has extra electrons, making it negative. So when a diode is installed forward biased, then the electrons in the N side flow into the P side and it works. Now, if you take that diode and you install it reverse biased, there's no electrons in the P side to go into the N side, so it doesn't work. Well, now we're taking it and we're making a sandwich between these things. And we are going to join two P's and an N or two N's and a P. And we're going to have some different arrangements that this comes into and that these things can do. And these are called transistors. Every driver that turns on a fuel pump or turns on lights or turns on power door locks or dimmer lights or canister purge solenoids all use transistors as drivers. So inside the computer are a whole bunch of these things. So that being said, let's take a look at what they are, how they work, and the classifications for these things. All right, so the basics, right? What is it? It's a 3-terminal device. It's made of semiconductor materials, and it can act as either an insulator or a conductor by applying a small signal voltage. The transistor's ability to change between the two states, on or off, allows it to have two basic functions, switching or amplification. So bipolar resistors have the ability to operate within 3 different regions. Okay, before I tell them to you, on or off. That's the way these things work. Think about a relay. We have a relay. The relay takes a voltage that operates a magnet that allows a high current to flow through. Kind of like an amplified signal, or a tenth of an amp, controlling 30 amps. Kind of like an amplification. So I want you to think that way when we talk about these things. Right? So there's 3 different regions that operate in a transistor for it to do its job. We have an active region. The transistor acts as an amplifier. This is the part that takes electrons and moves them someplace else. Right? But obviously, less effort turns greater effort. A saturation region. The transistor is fully on as a switch. So we have the ability to turn it on, and when we turn it on, there is a flow. And we have a cutoff region. The transistor is fully off, operating as a switch. So we have an area where stuff moves, an area where stuff stops, and an active one where we are growing our signal, so to speak. Right? So when you look at this picture, you're looking at 2 things. You're looking at what a transistor really is. You can see that you have an emitter, a base, and a collector. And then you have this symbol for a transistor off to the right. And you can see the emitter has an arrow. The base comes off like a T. And then the collector on the other side. And all 3 of those things are going to play a role, whatever type of transistor is designed into a circuit to do a certain function. So this is how they're made. What's in them? How are they designed? These are considered bipolar. We have a P and an N. Obviously, we have poles. Right? Bipolar means we have 2 different polarities mixed in with this. They're either a NPN or a PNP transistor. If you look at the picture on the right, on the left side of it, you'll see a PNP. That's 2 positives with a negative in the middle. To the right of that is an NPN, which is 2 negatives with a P in the middle. And you can see your emitter, your collector, and your base. And you see that on the other side too. Now note, just in the mere construction of things, the middle of a PNP is negative with an extra electron, and the 2 outside edges are positive. So obviously the electrons are going to have a role with what goes on the outside. On an NPN, our extra electrons are on the outside And obviously, they have an influence on the P in the middle. The arrows indicate current flow. So if you look at these, you can kind of see there's a few things in play, right? You have current flow in the PNP coming in on the emitter, moving downward to the T. You see current going down into the base. You see an arrow going out the collector, out the C. You also see these arrows that are curved between the emitter and the base and the base and the collector. They play a role, which is why they're there. If you look on the right one, you'll see that we have arrows going in the other direction, right? So the current is coming in on the C, going down towards the B, up towards the E, and you see current going up the B, and you see these curved things between the E and the B and the B and the C, right? So you see some different directions of stuff, right? So I'm gonna move my face over here again. I want you to look up above in the middle, all right? So there you're gonna see diodes. They're diodes, right? So you can see that you have a diode pointing at another diode in a PNP, and you have two diodes pointing away from each other in an NPN. Notice also in a PNP, you have an arrow pointing in towards the base, and besides my face, you see an arrow pointing away from the base towards the emitter. So obviously, we have some things that are going to happen. Now, I also want you to notice a positive and a negative, and a positive and a negative, and a positive and a negative, and a positive. You can also notice here you have a positive and a negative, and a negative and a positive. So when you follow current flows, those things will make sense to you. Just keep them in mind. Go back to this if you need to. The only difference between those two, the biasing of the diodes and the polarity of the power supply for each. One of these has power coming in, and this other one has ground, right? So you're going to see how that plays out. Now, this is a diagram I found when we had our NJ car competition, and I love it. Look at the symbols, okay? You see a B, a C, and an E. The B is the base, the C is the collector, the E is the emitter. Now, if you notice, it says if a small current flows between the base and the emitter, a high current can flow from the collector to the emitter.